Hi, my name is John Saville, and in this video I want to walk through some of the basics of Azure Infrastructure as a Service by creating a virtual machine. And not just creating an empty virtual machine, but create a virtual machine running a Minecraft server. I've done this before in the old portal and using the old Azure Service Manager, but I wanted to update it for the new portal and also using the Azure Resource Manager because things are very different. So I thought, let's go ahead and create a new VM using the new portal and the new resource manager. Now, if you don't have Azure today, if you have an MSDN subscription, you get a certain amount of credit just with that MSDN subscription. You can navigate and look at the Azure benefit for Visual Studio, and depending on the level of Visual Studio and MSDN you have, you'll get a certain amount of Azure credit every month. If not, you can sign up for a free trial account. This will give you $200 to spend in a month to just try out all the various parts of Azure. Obviously, if I'm an enterprise, I can have an enterprise agreement. I pre-buy a certain amount of Azure credit for the year, and then I can use that. I can pay as you go. There's different ways to get it. But what I want to focus on today is just about using that Azure service. So this is the Azure Portal. I go to portal.azure.com and this is what I get. I start off in my dashboard and it's pretty intuitive. I can customize this experience. I can click the customize button. Then I can resize tiles. I can pin different resources to this dashboard. I can navigate between the things I currently have open. I can browse through all the different types of resource I have. Now I'm focusing on the portal today just to walk through the various components, the different parts of Azure. But I do want to stress, yes, this is a great place to start. Yes, it helps me understand what I can do. But this should not be my main point of using Azure. For automation, for orchestration, for repeatability, I really want to be using PowerShell. I want to be using JSON templates. Now, I'm going to focus on creating resources in a particular region. I'm going to create a virtual machine. Now, a virtual machine needs certain things. I have to put it on a virtual network. I have to have a storage account to store the persistent operating system and optional data disks. They all have to be in the same region. And when I look at this map on the dashboard, I can see Azure has regions all throughout the world. There are regions in the US. There are regions in Australia, there are regions in Europe. They really are distributed everywhere. I can go and take a look at it. So if I navigate to this Azure Regions page, I can see, yep, there's the US ones. I have Europe, Asia, Japan, Brazil, Australia, India, China, Canada. Germany is coming online, United Kingdom, Korea. So a huge number of regions. And when I have an Azure subscription, I can create services in pretty much any of those regions. There are some restrictions around, obviously, Department of Defense ones, government, China, Australia. But for most of the others, I can just go and create resources there. Now, when I go and create a resource, if I create a virtual machine, if I create a storage account, often it will ask me, do I want to create this classic or do I want to create this in Resource Manager? And I want Resource Manager. This is the new shiny engine that drives Azure. It gives me things like JSON template-based deployments, massive parallelism. I can deploy 100 VMs the same time it would take me to deploy one VM using the old Azure Service Manager. I have role-based access control. So everything I'm going to do today is going to be using the Azure Resource Manager as my deployment point. Now when I do this, a fundamental concept of Azure Resource Manager is the resource group. Now, resource groups can be heterogeneous or homogeneous. For example, I could think about, well, I have a project, and this project has storage accounts and networks and SQL databases and websites. I could say I want to put all of those in a single resource group because they share a common life cycle. I'm going to create them together, delete them together. I want role-based access control over those. So it makes sense to put them together. Or maybe I manage things differently. Maybe I manage by, well, I have a storage person, I have networking. I'm going to put those each in their own type of resource groups. That would be homogeneous. All my storage accounts in one, or my networks in another. I'm going to go ahead. The first thing I'm going to create is a resource group. Now I don't have to do this. Technically I could just go and create a virtual machine. It would automatically go ahead and create a storage account, a virtual network, and resource groups. But when I think bigger picture, I don't want to do that. What I actually want to do is I want to control that naming. I want to put multiple virtual machines on the same virtual network, use the same storage accounts. So I'm going to create all of this up front. So I'm going to say new. And from here I can pick the type of resource. So it's showing me everything in the marketplace. But I can just search for resource group. And it was there on the navigation menu as well. So I'm going to say I want to create a new resource group. Now I'm going to create this heterogeneously. I'm going to put everything in together. My storage account, my network, my VM's network adapter. So I'm going to say it's a resource group. I'm going to create it in East US. I'm going to call it Minecraft. I pick the region. So I want to create this resource group in. Now, resources are not actually bound to the resources group location. I could create this in East US and it could still contain resources from other regions. Likewise, it's not a boundary of usage. If I had a virtual network in one resource group, I could still use that resource group's virtual network from VMs in different resource groups. So don't think of it as this wall. It's a container to contain resources that I can use for role-based access control, but it's not a wall within how I can access things. So I'm going to say East US. I don't want to pin it to the dashboard, but notice that option is there. So now my resource group is created. I'm going to go ahead and create those other resources. So the first thing I want is a virtual network. So I'm going to say new. And again, I could browse these things. So I can say there's virtual network. I want Resource Manager, not Classic. I want to use ARM. Now what this enables me to do is specify an IP space and also DNS servers that I want to use in Azure. The IP space I select should not conflict at all with what's on premises. It should not conflict with any other virtual networks that I'm going to actually go ahead and create. Basically, if I have overlapping IP ranges, it's going to make it hard to connect them together in the future and route packets between them. So I want to pick a unique space. I'm going to pick something that I'm not using anywhere else. And also, once I create this virtual network, I can use site-to-site gateways. I can use ExpressRoute to actually connect this to my on-premises. So I'll give this a name. So I might call this, it's a virtual network, and again I'm putting in East US, and I'll just call it my 10.1. And I'll use the default address space for right now. That's actually fine for what I need. By default, it's going to create me a subnet. So a virtual network is an IP space, and I break that up into subnets the same way I would on premises. So maybe I'll just call this, don't want to call it default, I'll just call it subnet 1. Now if I was going to do static IP address assignment like a DHCP reservation, I want to create a separate subnet for that. I don't want to mix dynamic allocation with reserved IP addresses. The way VMs work in Azure, they always get their IP addresses via DHCP. I can't statically assign a virtual machine an IP address from within the virtual machine. It has to get it through DHCP. But at a fabric level, I can absolutely say, hey, always give it this same IP address. When I do that, I would create a different subnet for like my reserved IP addresses. Otherwise, there could be a risk that, hey, if that VM wasn't running, then another VM started first, it might grab that IP address. Everything gets created in a resource group. I already created it. So I'm going to go ahead and select my resource group for East US. Notice if I wanted, I could change the location. I'm not bound to the location of the resource group. But I'm going to go ahead, create an East US. Again, I don't want to pin it to the dashboard. So I'm creating the network. So that will give me something to connect my VM's network adapter to. Now I need a storage account. So I can just go to my storage account. So I can click new, I could browse. I'm going to add a new storage account. Now this name has to be unique throughout all of Azure. So I'm going to say it's a storage account and it's in East US, and I can actually use lowercase, yep. So I'll say storage account, East US, Minecraft. And that name is available. I want Resource Manager again. I want general purpose. Now there is also blob storage. If I select blob storage, I could do cool tier or hot tier. Cool is a cheaper price for storage, but it's a higher cost to actually perform transactions against it. Designed for data I'm not going to use very much, but I need it kept. I cannot use that for VHDs. VHDs is what I use for VMs. I have to store that in a page blob, which is not supported in the block blob storage. So I'll say general purpose. I'm going to use standard tier of storage. There is also premium. With premium, it's higher IOPS. It's predictable IOPS. But I don't need that for that. To use a premium storage account, I have to use a something S series. So a DS, a GS, and FS series virtual machine. I pick the replication I want. So locally redundant means there's 3 copies of the data just in my local region. Zone redundant doesn't really apply to our page blobs, but it would give me 3 copies of the data distributed over different data centers within a region. Geo-redundant says 3 copies of the data. It's then asynchronously replicated to the paired region, which is hundreds of miles away, East US to West US, North US to South US, etc., where I have 3 copies of that replicated region as well. I'm just going to say locally redundant, I don't need it replicated. I'm going to once again use my existing resource group. And again, I want it in East US. I have to have the network and the storage account in the same region of where I want to create my virtual machine. So I'm creating my storage account. Now if I actually went and looked at my resource groups, if I go and look at my resource group, I'll start to see the resources being created within it. There I can see I've got my network and I've got my storage account. So the next thing is to actually go ahead and create the virtual machine. So I'm going to say a new virtual machine. And there's a huge number of templates available to me in the Azure Marketplace. It's 64-bit operating systems, so Windows Server 2008 R2 and above. There's a huge number of Linux distributions supported, and I can kind of see some of those here. I'm going to say a Windows Server 2012 R2. Again, Resource Manager. So now I configure those basic settings. I give it a name. So I'm going to say it's a VM, it's East US, and it's my Minecraft server. I give it a local username. Oh, it's too long. Does that work? There we go. I cannot use administrator, so I'm just going to call it local admin. I give it a password. I think it's 12 characters is now the minimum. We can test that quickly. Let's take some of these out. Yep, 12 characters. Pick my subscription again. Once again, I'm going to use my existing resource group. And I want to create it in East US. That's important now. So now I pick a size. There are various series and sizes of virtual machines. If I do view all, now these will vary by region. Typically I'll start with the A series. The A series is how Azure started, and you see there's a lot of different ones available. So the A0 is a shared core. I can have one data disk which can have 500 IOPS. An A1 has a whole core, nearly 2 gigs of memory. I can have 2 data disks. A2 has 2 cores, more memory, all these various different sizes, different combinations. I can also have a different number of network adapters depending on the size of the virtual machine. But the A series essentially has different core and memory combinations, different numbers of data disks, and it has a hard disk drive based temporary disk. This is like a scratch drive. The page file is put on it. It's not persistent. I don't put any data I care about it on it, but I have these various different combinations. Now then there's also a basic for the A series. Notice it has lower IOPS, doesn't have auto scale, doesn't have load balancing. It's designed for test dev. I want to be as cheap as possible. In addition to the A series, there is the D series. The D series is really the same sorts of combinations, but that temporary hard drive is SSD based. Actually, that's the DS. Find the regular D series. There we go. There's a D2. So D1. The V2 means it's a higher spec of processor. You pick, do I want a V1 or a V2 for the D series? So I get predictable performance. There's an F series. The F series gives me a large amount of cores for a proportionally smaller amount of memory. So there's the F series. And you'll notice for a lot of them there's also like an S version. The S version means I can use premium storage. Regular F can't use premium storage. There's also a G series. The G is the Godzilla. These are huge virtual machines. And Microsoft does have a page that walks through all of these different sizes. You can go and look that up. But I pick a size I want that meets my requirements. So for right now, just a regular Minecraft server. I'm not going to do a lot on it. I'm going to pick an A2. I'm going to use standard storage. I pick a storage account. I can only pick storage accounts in the same region. I have others, but I only have one in East US, so that's the only one I can select. Same for the network. By default, it's selecting the only one I have in East US. It's picking the first subnet. Now it's also giving me something called a public IP address. I don't have to have this. We're going to use this later on. But this is really just to expose the virtual machine to the internet. By default, it'll have an IP address on that subnet. That's called a private IP. It's the same thing we kind of use on premises through the RFC 1918, a 10.172.16, or 192.168. But what if I want to advertise a service out to the internet? So one way is to give the VM a public IP directly. Every bit of traffic going to that public IP will be sent to this virtual machine. Or I can create a load balancer. I can create a load balancer object. I can give the load balancer a public IP, and then either load balance traffic between different virtual machines, or I can actually do port forwarding, like a NAT rule. Say, well, everything on this port, send it to this particular virtual machine. By default, it's adding me a public IP. I'm going to leave that for now. I'll have that. And also it creates a network security group. A network security group is applied at the VM level, and it basically controls the type of traffic that can flow in and out. I can add various extensions. There is a VM agent added to the virtual machine. This is for my benefit. It gives me PowerShell and Portal abilities to reset local passwords, to fix the RDP stack if I do something silly. It lets me interface with anti-malware solutions, PowerShell DSE, Chef, Puppet. It's just a way for the fabric to work with partner solutions to add value. I can turn on monitoring. Availability set. Now this is critical, but I'm not going to use it because I'm creating a single VM. But ordinarily, for a production service, you want to create at least 2 instances. And I have to put those 2 instances in an availability set. Because Azure has to do maintenance. Things can fail. So I always want to have 2 instances for high availability, maybe for scale, and 2 at minimum. Now when I add my 2 instances of, let's say, a SQL database, or domain controllers, or web servers, I want to make sure Azure doesn't put them on the same rack. A rack has top-of-rack switches, power supplies. It could be considered a fault domain. Something could go wrong and take out the rack. So I want to make sure my 2 VMs, or 3 VMs, 10, whatever, they're put on different racks. And by putting VMs in an availability set, I'm telling Azure, hey, these VMs are doing the same thing. They're part of the same service. Split them up over for Azure Resource Manager 3 different fault domains, so 3 different racks. They're also used as part of routine maintenance. So there's also something called update domains, and it will spread the VMs over 5 update domains. So during planned maintenance, I don't lose all my instances, only a fifth would come down at any one time. So it's very, very important I use availability sets for any kind of production workload. But I'm just creating a single VM, so I'm not going to put it in an availability set, but under normal circumstances, you definitely should be. It's giving me a summary, and we'll say go and create my virtual machine, and we'll let that cook, and we'll come back to it when it's finished. I can see if I scroll over, it actually pinned it to my dashboard. So here's an easy way I can track of what it's doing. I can just click on that to see the detail. As I look at that detail, I can see everything it's doing. So it checked the storage, checked the network, goes ahead and creates the network interface. So it created first a public IP address, it created the network security group, and now it's actually creating the NIC and connecting it to that private IP, connecting it to the public IP, and then once it's created the NIC, now it can go ahead and create the VM that's going to use that NIC. So I can actually see this creation and the order in which it actually does stuff. Okay, so that VM is now finished creating, and here it is. Now before I do anything else, I can absolutely at this point log on to it. It's giving me a nice little connect option that will create an RDP file using that public IP address. But I actually don't want to connect to it yet. What I want to do is add a couple of data disks. The reason I'm doing that is I get an OS disk by default, but I really don't want to put my application data on there. By default it has read-write caching. I would rather create data disks. I can control the caching. I can create multiple of them depending on the size of the virtual machine. Now each data disk is a terabyte in size and 500 IOPS. Now what if I want more than that? Well, I could use premium storage that has higher IOPS. But the other thing I can do is actually just add multiple data disks. For example, if I go to my disks, I'm going to attach a new disk and I give it a name. So I'm just going to call it VM US Mine Data 1. There's the size. I don't want any caching. It's going to create it in my East US account. Now you may wonder, okay, I'm creating this as 1 terabyte. Azure is consumption based. I pay for what I use. This is a fixed size VHD, which means it pre-allocates all of this space up front. So does that mean I'm going to pay for 1 terabyte, even though I might only write 20 megs to it? Well, the answer is no. Behind the scenes, Azure uses sparse storage. So what that means is it only actually charges me for the data I actually write. So if I create 4 data disks, I aggregate them together to aggregate the IOPS, and I write 100 megs, I pay for 100 megs. I pay the same as if it was being written to 1 disk. But now I get 4 times the IOPS, so it's actually a good thing for me there. So I want to use that capability. So I've attached 2 data disks that will show up once it's finished provisioning, and I'll see those within the virtual machine. Now to connect to this thing, it has a private IP and it has, because it added it, a public IP. So I could RDP to either one of those. Now, right now, this virtual network I created isn't actually connected to my on-premises network. So that private IP address is only useful for VMs on that virtual network. So I can't connect via that. So I have to connect via the public IP address. If I look at my network interfaces, I can see I have 1 network interface. I have a private IP and a public IP. So I'll have to connect via that public IP address. If I select that, I can see the IP addresses I have. I can see it's a public IP address. That's what it is. I could select that and it would have created me a new public IP. It's already using it. I can see I have a dynamic private IP. I can see I have a network security group. So this controls the security. So what we'll actually do is we'll take a quick look at that. So let's look at that network security group. So if I go and do browse, I'll look at my network security groups. If I look at this one that it created automatically, and I look at my inbound rules, it actually added one for RDP from any source to any source. Now it also has default rules. So the default rules basically say any traffic from the virtual network to the virtual network, now that does extend out to connected networks. That becomes part of that network. They're allowed to connect. My action is any service, any port, my action is allow. So I'm going to let that through. Everything else I'm going to deny, except for the Azure Load Balancer itself. So it has a specific rule to enable RDP connections in, which is port 3389. So that's why I can RDP to this from the internet. It added a special rule just to allow RDP in. So at this point, I can go and browse back to my virtual machine. I can connect to it. So by opening this, it's opening an RDP file, and I can connect to my VM. Now if I look at the RDP file, I can see it put in the IP address of that public IP, then added the RDP port to it. Now a public IP address also can have a DNS name. If once again I go and browse, and I just look at my public IP addresses, I'll see the public IP address it created. If I select that, I can look at its configuration. And you'll notice by default it does not have a DNS label and it's dynamic. So if I completely shut down this VM and didn't use it anymore, I might get a different public IP address next time. Or I could say, give me a static one. But I could add a DNS name. I could absolutely say, well, this is my VM East US Minecraft. Let's see if that's too long. Oh, only lowercase. Okay. So we'll just change that. VM East US. Oh, Minecraft. So as they're checking, is that name unique in East US for Cloud App Services Azure.com? So now I'd be able to use that name to actually connect to my virtual machine instead of having to use the IP address, because especially if it's dynamic and it could change every time I restart the VM, that's a pain to keep checking, well, what's the IP address? Now I could just use this DNS name instead. So I'm going to save that. So it's now available to use to connect to this virtual machine. So I'm going to put in what I know is my username is local admin. We'll say connect. Needs the password. So that's what I configured. Yep. And now it's opened a connection. Open it over here. But now this is my virtual machine I created. So that was using that public IP address. Now we could also test, well, what about that DNS name we added? Is that going to work? So now I have my virtual machine. I could go and test. Well, let's look at that name. If I do an NS lookup on the name, so this is quickly enable, quick edit. Yep. So I could absolutely use that name. That public IP address now has a DNS entry. Now if I look at this virtual machine, what do I have right now? So I have my OS drive and I have that temporary storage. It's called temporary storage. It has a big warning on it. And what actually happens behind the scenes is it's also, let's look at the options. It's putting the page file on there. It's scratched, doesn't matter if that gets lost, it's really not the end of the world. So that's what it's doing with this. But where are my data disks? Well, it just created the disks. They don't really exist yet. They're not partitioned. If I go and look at Disk Manager, I'll see my 2 disks here. So it's saying, hey, do you want to use them? Yes, I'll initialize them as GPT. And I'll have my 2 disks. There they are. Now what I want to do is I want to use those within the VM. But what I'm going to do is I want to aggregate them together. And the way to do that in Windows Server 2012 is to use a storage space. So I'm just going to super quickly create a new storage pool. I'll call it my store pool. I'll add in those 2 disks. Create. So it's going to give me a 2 terabyte volume with the aggregated IOPS. That's going to be 1,000 IOPS instead of 500 IOPS. Once that's completed, I'll create actually a volume on there. Now, I don't need mirroring. I don't need parity. Remember, each of those disks is already replicated 3 times. So all I need is a simple volume, just like striping. Data disk, simple. Fixed it, pre-allocate it all up front to maximum size and create it. And that's it. And then all I have to do is create a volume on it and format it, which it will run the wizard for me. I'll just call it data. Now I'll have a data disk as well. If I go and look again, once that's completed, I'll see an F drive. And that's where I could store my Minecraft data. I don't want to put it on the OS drive. I don't want caching. I'll put it on that F drive it's creating for me as we speak. Now, one important thing to do when you're using this is always do a quick format. So remember I talked about its sparse storage. Well, if I did a full format, it would go and write zeros to everything. Therefore, it would write data. Therefore, I'd get charged for that. So I always want to make sure a quick format is performed so it doesn't try and fill up the disk with a bunch of zeros. So right now it's just doing that quick format for me. And then it's going to update and give me that as an F drive. So that's completed. And there's my F disk. And on there, I'll go ahead and create a folder. So at this point, I have a VM. I have a VM with a data disk. I have 1,000 IOPS because I aggregated 2 disks together. I'm really good to go. I had that network security group which allows me to RDP via that public IP. If I was connecting the virtual network to my on-premises, I'd also be able to use that private IP. And I wouldn't want to publish RDP to the internet. It adds it by default because, hey, I'm creating a VM from the portal. I'm going to get very confused if I couldn't connect to it. But generally, I wouldn't want that. For my production workloads, I don't want to publish RDP to the internet. I don't want to publish WSMan to the internet. I would connect to those through a secure on-premises to Azure network connection, the site-to-site VPN or ExpressRoute. So once I have that, I would go and turn off that NSG exception. The only NSG exceptions I should have to the internet would be things I want to publish, HTTP, HTTPS for a website. Now in our example, let's just carry this on. We want to install Minecraft. So I have to install Java, and I have to install the Minecraft server. Now in here, I just have a web browser, so I can open up Internet Explorer. So even without a public IP, I can still get to the internet. That private IP, Azure actually will act as the gateway. So here on this virtual machine temporarily, I want to turn off the enhanced security. So I do want to go and browse the web. Just going to relaunch that quick. So if I go to Minecraft, I want to download the Minecraft server. I want to set up your own Minecraft server. So I'm going to download this file. So I want to save target as, and I want to save that to my Minecraft folder. So go in here, save. Now I need to install Java. So what is it? It's actually a Java runtime environment I need. So say download. I'm going to run this, so complete this installation. Okay, Java is now installed. So it should be good to go. If I look, I can see the java.exe and the java.w files. And at this point, what I'm going to do is just super quickly open up a notepad and just create a little file that I can just use to copy in the command they say to launch it. And I'll actually go ahead and save that to my Minecraft folder. Now notice it calls it Minecraft server.jar. So we'll rename that file. At this point we have Java, we have our start file. I just realized I have a space, so it's not going to work very well if there's a space. So we'll save that again. So it's launching it. It's creating some log files. And what it's done is it's created some configuration files, but by default it's not very happy. We have to accept the EULA. There are some other configs. So if I update the EULA, I can change this to EULA true. Again, my goal here is not really a deep dive on installing the Minecraft server, but I could also go and, for example, change some of the properties of the server itself. If I try and now run it again, now it's actually creating that server, saying I actually go and connect to. So now I have my Minecraft client. So at this point we know the address we can connect to. So does it actually work? Well, we wouldn't actually expect it to yet, because I'm going to connect via the public IP. So if I do multiplayer, I say add server, and I give it the server address. It's trying to connect to that address. And I don't expect this to work, because I'm trying to connect via the internet. Well, Minecraft doesn't use a standard port. It's not already open. So I'd expect this to actually fail, and it's going to fail for two reasons. Firstly, the VM itself. So inside the guest OS, it has a firewall. So I have to create an exception for the Minecraft traffic within the operating system first, or it can't possibly work. Let's go to my inbound rules. I'll create a new rule. It's based on a port. Minecraft uses a particular TCP port, so it's TCP, and the port is 25565. I want to allow it in. So let's try it again. But remember, I have that network security group. That network security group blocks everything except RDP. So what I need is another allow rule. So I'm going to add a rule. I'm going to give it priority 1010. We'll call this one Minecraft. Now the source can be from anywhere. It's TCP. Not sure what port it comes from, but we'll say the destination has to be port 25565. And then my allow will be allow the action. But I'm pretty sure it's TCP. Now, instead of allowing it to everyone, I could pick a particular CIDR block, i.e. IP address and a number of subnet mask bits. But I'm just going to allow that through. So that's creating a new rule just to allow my Minecraft traffic to flow through. So it's updating. Once that's finished, so it's now there. Let's try that again. Connect to the server. So now the VM has the exception and the network security group has the exception. And I'm in. So that was it. I can now wander around in my nice shiny Minecraft server. Now there are other things I might want to do. I might want to go and make myself an administrator, and there's all sorts of things that I can actually do other configurations. In fact, I've just locked myself in a cave. But that was it. So if we look at exactly what happened there, we created the virtual machine. We added a couple of data disks. We installed Java. We installed an application. I opened up a firewall exception for the application. I updated the network security group rule to allow that traffic into the public IP. Now again, if I was connecting to this from within my network, I had a site-to-site VPN, I had ExpressRoute, I wouldn't have to do this. This is only because I'm using a public IP. And again, normally I don't want RDP, I don't want WS management, I don't want Minecraft published out, well, Minecraft I probably do, I want published out to the internet. I only enable exceptions from the internet for things I want to publish to the internet. There are actually special codes for the internet. So I could block it for everything and just enable 80 or 443 in from the internet to a certain range of machines. And although I've got one NSG for a VM, I can create these NSGs, I can apply them to subnets. I can apply them to any VM in that virtual network subnet. So that's it. We created a VM pretty quickly. There's one other thing I wanted to just talk about for a second. The VM is provisioned. I'm paying for this virtual machine. Now, maybe I'm done with it. Maybe I'm done with it for the night. I don't need it running anymore. I'm honestly not even sure the right way. There we go. Terminate. Yes. Stop that. I actually think, now notice there's actually players. I could add myself to the admin list here. My file, I said no GUI, but I think if I take that off, it will actually open up the graphical interface to show the Minecraft server. There we go. So I can see the various bits of information. I'm just going to close that down again. So I'm done with this. So I'm going to say, okay, shut down. So does that mean I've stopped paying for it? It's now shut that thing down. And through the VM agent, through the heartbeat, and it will detect that it stopped. But it's just stopped. It still has a space reserved on the Azure Fabric. It's not been taken off of a host. So I'm still paying for that thing. So it's important to understand. When I think about Azure, one of the huge things is it's consumption based. I pay for it when I'm using it. But if I just leave it running 24/7, I'm not getting the true value. Very few applications really have to run 24/7. They need to run at certain times. Maybe half the instances of my website can be shut down at night, on the weekend. So right now, I'm still paying for this, and eventually this will say stopped. Let's try and refresh. So it's still unknown. Can't talk to it right now, but it'll work out soon enough. It's stopped. Still unknown. What I want to show is it actually going into that stop state. Okay, so it's gone to stopped. I'm still paying for it. And it's going to try and be nice. Hey, stopped, you're still paying for this thing. If I want to stop paying for it, I have to shut it down. I have to stop it from the portal or through PowerShell. If I now say stop, it will change to stopped deprovisioned. That's when I stop paying for it. So if I'm going to use Azure, I want to make sure I get processes in place to actually stop the VMs when I don't need them anymore, and actually deprovision it from the fabric. Now, I'm not losing anything. Well, that's a lie. I will lose the contents of that temporary drive. If I have dynamic IP addresses, its IP address may change when I start it again. Again, if I want to make sure it keeps the IP address, I can do static IP address assignment, both for that public IP and for my private IP. Once this updates, I'll actually see it saying stopped deprovisioned, and I'm not spending my money anymore. The only money I'm spending is on the storage account, where it actually stores that OS disk and where it's actually storing those data disks. I can look at that storage account. If I go to storage accounts, I can see there's my Minecraft. I want to look at my blobs. I'll have a container called VHDs, and I'll see three. I'll see my OS disk, my data 1, and my data 2. So my 3-page blobs that make that up. Again, I can navigate around super quickly, all the things I'm looking at. Here I can jump back to my virtual machines view. Still updating. Again, eventually that will go to stop deprovisioned, and I know I'm not paying for it. And there we go. No longer spending my cash. Again, when I wanted to start it, I'll just right click and say start. So I hope this was useful. We walked through a fair number of core concepts, but that's everything we need to get up and running. Now in production, I'd want to connect my virtual network to my on-premises through the site-side VPN or express route, and I could just use that as an extension of my data center, and I would remove those exceptions to publish this out to the internet for RDP and really only publish out my Minecraft server. Hope this was useful. To see more of the videos and what I'm up to, please follow me on Twitter at NTFAQGuy. Thank you.